Hello, today's video is on Chapter 2, Section 4, Writing Equations of Lines. There are three different forms that you need to be able to write equations in. The most familiar is slope-intercept form, which is y equals mx plus b. Second is point-slope form, which is y minus y1 equals m times x minus x1, where you have your slope m, and you're going to plug in a point x1 comma y1. And last is standard form, that is ax plus by is equal to c, and that basically just means that you have your x term first, your y term second, and it's set equal to your number. You can't have any fractions or decimals in standard form. So when we go to write equations, we want to write the equation first in point slope form. So if you want to write it in point slope form, you need two things. One, a point, and two, a slope. So our slope is 3, our point is 4 comma negative 2. This is our x1, this is our y1. So we go to our point slope form, and according to the general form, it's y minus y1, and in this case it's minus a negative 2, which makes it a positive 2, equals m, our slope, and m is 3 in this case, parentheses x minus x1, and our x1 is 4. And you're done. So all you're doing for point slope form is plugging in the point and the slope. So when we go to number 2, we're given 2 points. We have a point, we don't have a slope. But when you're given 2 points, you can find the slope, y2 minus y1 all over x2 minus x1 minus a negative makes that a positive 2. So we've got 8 over a negative 6, and we found that our slope is a negative 4/3. When you go to write in point slope form, you've got to choose one of your 2 points. It does not matter which point you choose. So if we were to choose our first one, it would be y minus y1. And remember, this is our x1, this is our y1. So y minus 14 equals our slope, which we found, of a negative 4/3. Parentheses, x minus an x1 minus a negative 2 makes that a positive 2. Okay, so moving on from point slope form, next we have slope-intercept form. So if you're looking at the equation in slope-intercept form, you can see two things, the slope and the y-intercept. When we look at number 3, we're given the slope of 1/2, and then you're given a point. You have to determine, is this the y-intercept? We do know that this is our y-intercept because the x-coordinate is 0. Anytime the x-coordinate is 0, you are given the y-intercept. So we've got y equals mx, and our m is 1/2, our slope, plus your y-intercept, which is a negative 12. When we look at number 4, we're given our slope. We're given another point of negative 3/8. This is not the y-intercept. If it's not the y-intercept, we can't just choose, oh, okay, I'm going to put 8 in the equation the way I put negative 12 in. When you're not given the y-intercept, you have to either find the y-intercept or start in point slope form. So y minus 8 equals your slope of 1/3, x minus a negative 3, which makes x plus 3. And then we can take point slope form and change it into slope-intercept form. So we can distribute that 1/3. Y minus 8 equals 1/3 x. 1/3 times 3 is 1. And then we solve for y. Add 8 over. And we've got y equals 1/3 x plus 9. And you've changed your equation from point slope form into slope-intercept form. Alright, so when we look at number 5, slope-intercept form, we're not even given the slope and we're not given the y-intercept, so we can start by finding the slope. 6 minus 6 over negative 2 minus 3. 6 minus 6 is 0 over negative 5. That gives me a slope of 0. Anytime you have a slope of 0, you know that you're going to have a horizontal line. And horizontal lines have special equations. Hopefully you remember that they're y equals some number. If you forgot that, when we look at our points, we've got 3, 6, negative 2, 6. Notice that both of your y values are 6. Therefore, the equation of that horizontal line is y equals 6. Going on to number 6. Again, we go to find our slope. 9 minus 0 over 4 minus 4. That gives us 9 over 0. We have an undefined slope, which means we have a vertical line. Every vertical line is x equals some number, and if you forget, you see that both of the x coordinates are 4. Therefore, the equation that line is x equals 4. Now, you can just look at your 2 points and say 3, 6, negative 2, 6. Oh, well, they both have y value of 6 and go directly to the equation. Or for 6, you have 4, 0, 4, 9. Okay, the equation is x equals 4. You can do the slope if you don't recognize it from the very beginning, but you don't have to show the slope. You can go directly to the equation only for vertical and horizontal lines. Alright, so let's throw some word problems in there. Carmen's mom is making spaghetti for the Warren spaghetti dinner. When Carmen comes home, her mom has made 4 servings of spaghetti. 4 hours later, she has made 52 servings. Write an equation in slope-intercept form that describes the situation. So first, when Carmen comes home, her mom has made 4 servings of spaghetti. You've got to think about your independent and your dependent variable. How many servings she has is going to depend on how much time has gone by. Therefore, servings is the dependent variable, which is the y, and the time she comes home, or the number of hours, is the x value. So hours is the x coordinate. She comes home and there's 4 servings, so 1 point is 0, 4. 4 hours later, she has 52 servings, so that's 4, 52. From there, we go to find our slope, 52 minus 4, all over 4 minus 0. Remember, y2 minus y1, x2 minus x1. That gives us 48 over 4, which is 12. And you've got to know that in this case, that's our rate of change, that's our slope. On top, we were doing servings. On the bottom, we were doing hours. So our rate of change is 12 servings per hour. In this case, to write the equation, it's actually not as hard because we are given the y-intercept. We know it's the y-intercept again because our x-coordinate is 0. So we can go to y equals 12x plus 4. Number 8, write the equation of a line that is perpendicular to x equals 5 and through that given point. Well, x equals 5, that is a vertical line. So if you have a coordinate plane and you have a vertical line, the only line that's going to be perpendicular is a horizontal line. So I know if I went perpendicular to vertical, I'm looking for horizontal, and we know that horizontal are y equals some number. So if I went to go through 2, negative 3, I take the y coordinate, so the perpendicular line going through that point would be y equals a negative 3. For number 9, we've got write the equation of the line that is parallel to y equals 10 and through that given point. So y equals 10, that is a horizontal line at 10. If I want it to be parallel, I want another horizontal line, which means I want another y equals. So in this case, it would be y equals 11. So just remember the relationship between vertical and horizontal. For number 10, we want to write the equation of the line that is parallel to our given equation. Our given equation has a slope of 5. Therefore, our parallel slope is going to be the exact same, which is also 5. And we want it to go through the point, negative 210, and we want it to be in slope-intercept form. So we're given the slope, our parallel slope is going to be 5. We look at our point, that is not the y-intercept. So we start in point slope form, y minus 10 equals our slope of 5, x minus a negative 2, which is x plus 2. Distribute the 5, y minus 10 is equal to 5x plus 10. Add your 10 over, And we've got y is equal to 5x plus 20. I want you to try number 11 on your own, so press pause. When you are finished, press play and see if you got the correct answer. Alright, so we want our equation to be perpendicular. When we look at our equation, we pick up that our slope is 1/2, therefore the perpendicular slope is a -2. And we want it in point slope form, so we get y plus 3 is equal to our new slope of -2 parentheses x minus 4. Remember, you were given the point that you were plugging into point slope form. Okay, moving on to standard form, and remember, standard form is where your x is first, your y is second, and it's set equal to the number. But you can't have any fractions, no fractions, or decimals. When we look at our first one, we've got 5y is equal to 8x plus 9. Well, the very first thing that we should see in standard form is our x. So we're going to take that x and we're going to move it over in front. So to move it over, we subtract 8x from each side. And we've got a -8x plus 5y is equal to 9. Now technically also your a term should not be negative, so we're going to distribute a -1 throughout everything, making our first term a positive 8x, a -5y equals a -9. We look at 13, again our x is out of place, so we move our x in front, so we've got a -1/3 x plus y is equal to 4. Now there's two mistakes, or two problems we have to fix. First, we have to change that first term from a negative to a positive, and we have to get rid of our fraction. To get rid of the fraction, you always multiply by the denominator. So we're going to multiply the entire thing by a -3 to get rid of the negative and to get rid of the fraction. So -3 times a -1/3 is a positive 1x. You're always going to be left with whatever's in the numerator. Minus 3y is equal to a -12. And our last topic for today is direct variation. Direct variation is not as complicated as you think. A direct variation is slope-intercept form without that y-intercept. So k in this case is really acting like your slope. So we're just going to take k instead of m. When we say this, we say that x and y vary directly, where x is the constant of variation. Constant of variation, remember, is the same thing as your slope or your rate of change. So I'm going to tell you that x is 4 and y is 12. First thing you want to do is find k. So we look at our equation, y equals kx. Well, y we said was 12 and x is 4. So to get k by itself, we divide by 4 and we find that k is equal to 3. Remember, k is your slope. So then we're going to use that to write our direct variation equation. So y equals 3x. That shows me that my equation has a slope of 3, no y-intercept. Direct variation always starts at 0, 0, so there's no number there. And number 3, our last step, is to find y when x is 5. So our equation is y equals 3x, and we're told that x is 5, therefore y is 15. I want you to walk through those same 3 steps on your own and see if you can find x when y is -20. So press pause and try number 15 on your own. Alright, let's see how you did. So first, we want to find our constant of variation, our slope. So we plug in the 15 for y that we were given. We plug in the -x for x, the -6 that we got for x. And then we find that k is a -5/2. Make sure you reduce that fraction. That is our slope. So we plug that in for our m or our k to get y equals a -5/2 x. Next, we want to find out what x is when y is -20. So we replace the y with -20, and then to get rid of the -5/2 with x, to isolate x, you multiply by the reciprocal. -2/5 times -20 gives you your x value of 8. So remember, direct variation is simply slope-intercept form, your y equals mx plus b, where you're always starting at 0, 0, so there is no number added, and k is your slope. You're done.